we are on the home stretch. We are counting down and we're making sure that we are well prepared. So as usual, I have my PEP scholars in studio who will be joining me and helping me to work out the problems. The problems that we're going to be looking at were issued by the Ministry of Education here in Jamaica as part of their workshops that have been so useful, so helpful in guiding our students and preparing them for their exams. So we're diving into another round of questions, and I'm going to invite my scholars to join me. Welcome, everyone.
Night, miss. Night, miss.
Name.
Okay, so I'm seeing Amari, I'm seeing Nardika. Who else is there? I'm seeing Abriel, Jaim. All right, so everybody ready to go? And of course, other scholars will be joining us later, as usual. So let me share the screen and we can go right into it. So we're continuing with the questions that we were doing yesterday. We stopped at 23 and we're going to continue now. Items 24 and 25, and this is the quantitative reasoning. And of course, under the category of data analysis, the skills that are being tested here are analysis, so being able to analyze, interpret data, and to predict and draw conclusions. So we are advised to analyze the information in the table and see what pattern we can find. All right. So this is the table. Jaim, can you read for me, please? Can you hear me, Jaim?
Yes, miss. I can't see it well,
Oh,
miss.
I can't see it. Nardika, can you see it?
Yes, miss.
All right, go ahead, please.
A student investigates friction by pulling a block and recording the force needed using a force meter. The results are shown in the table. Use the information to answer items 24 and 25. A student investigates friction by pulling a block and recording the force needed using a force meter. The results are shown in the table. Use the information to answer items 24 and 25.
All right. Jaim, can you see this one?
Yes, miss.
Okay, go ahead and read the table, please.
Table showing the force needed for different surfaces. Surface force needed in tone in
Table.
newtons.
Oh, in newtons. Okay.
Newtons. Tabletop 2.5.
Newtons.
Paper
Say
paper paper.
newtons after each one.
Miss.
No, just say newtons after each. 2.5 newtons.
Oh, okay, miss. Paper towel 2.8 newtons. Fine sandpaper 3.0 newtons. Rough sandpaper 3.3 newtons. Table showing the force needed for different surface. Force needed in newtons. Tabletop 2.5 newtons. Paper towel 2.8 newtons. Miss, I can't see, Miss. The screen is loading, Miss.
Okay, fine sandpaper.
Fine sandpaper 3.0 newtons. Rough sandpaper 3.3 newtons.
Okay, thank you, Nardika and Jaim. All right, Abriela, could you read question 24, please?
What is the conclusion for this investigation?
Can you read a little louder, please, Abriela?
What is the conclusion for this investigation? A. Force move objects on different surfaces. B. Force stops objects from moving. C. The rougher the surface, the greater the force needed. D. The smoother the surface, the greater the force needed.
Okay, please read it again and a little louder.
What is the conclusion for this investigation? A. Force move objects on different surfaces. B. Force stops objects from moving. C. The rougher the surface, the greater the force needed. D. The smoother the surface, the greater the force needed.
Thank you, Abriela. All right, so they're asking us, remember the skills being tested, we're to be able to come to conclusion, to draw conclusions. What does it mean to draw conclusion? Anyone? If you're being tested for being able to draw conclusions, then you have to know what does it mean. How are you going to know if you have that skill? What does it mean to draw a conclusion? Let me pick up my scholars in the chat. Let me
Miss,
hear. Yes, go ahead.
miss, to draw a conclusion, to consider the facts of a situation and make a discussion about what is true, correct, likely to happen.
Okay, very good. Read it again, please.
Miss, repeat.
Read the definition again, please.
To consider the facts of a situation and make a decision about what is true, correct, or likely to happen.
All right, thank you very much. So, we are to consider the situation, the experiment that was carried out, and determine what have we learned from this. What can we say are the facts based on what has been happening? So if we look back at the situation, hold on. So we have four surfaces, and we're looking at the force that is needed to move different materials over the surface. Of course, the force being measured in Newton. A regular tabletop requires 2.5 newtons. Paper towel, 2.8 newtons. Fine sandpaper. Do you know what sandpaper is? Has anybody ever seen or felt
Yes,
sandpaper?
Miss. Yes,
Yes, miss.
Miss.
What is it used for?
Yes, miss.
What is sandpaper used for?
Miss, like for my experience of sandpaper, like it's for like rub it down paint and then you paint over what you rub down to like smooth the edges.
Okay, right. So we can use it to remove certain substances, but mostly it is used to smooth down surfaces. And the reason it is used to smooth down surfaces is because it itself is quite rough and gritty, granular, right? So the texture of it is rough, but we have two grains of sandpaper here. We have the fine sandpaper, and then we have a rougher, tougher, grittier sandpaper. So what can we say based on the force that is needed to move the substance over each of these surfaces? What conclusion can we draw? For A, force move objects on different surfaces. Yes, that is demonstrated, but I think more specifically, we found something out here based on the actual size of the force, the magnitude of the force that is needed. So yes, it was demonstrated forces use move objects. Forces can also stop objects from moving, right? You can apply a force to something and stop it from moving. So A and B are just basic statements of facts, but this actual experiment proves something even more. So which of them, C or D, did it prove? Is it that the rougher the surface, the greater the force needed, or the smoother the surface, the greater the force needed?
Miss, I would say the rougher the source is the rougher the surfaces is the more force needed, Miss.
Okay, anybody disagrees or agrees? Do you agree or disagree with Amari? So the tabletop, a regular tabletop would be relatively smooth, wouldn't it? And the paper towel is a little bit more textured because usually the paper towel you will have indentations in it because you want it to absorb. So it's made with those crevices deliberately to increase the surface area to absorb the moisture that you're picking up with the paper towel. And of course, we said the sandpaper is rough and gritty, and then we have the really rough sandpaper. So it's gradually getting rougher and rougher. And if we look at the amount of newtons needed to move the thing across this surface, excuse me, we need more and more force the rougher the surface gets. And of course, what is being demonstrated here is friction. Remember, it says the student is investigating friction. So friction is a force of resistance, and friction is very important. If we didn't have friction, we actually couldn't move very well, or we would all be sliding. We'd all be sliding around and bumping into each other. We actually need to have some texture, some roughness. That's why the soles of your shoes have those grits, those lines, those crevices to grip the surfaces that you're walking on, or you just be sliding, right? The bicycle wheel, the car wheel, that's why they have those rough surfaces to grip the road so the car doesn't skid, right? And there are conditions that make friction less, like if you grease it or if it is wet, then it makes things slide even more, whether or not they have the grip, right? So we do need friction, but too much friction can hinder movement. All right, so for this one, we're going with C. Let me get my marker here. We're going with C. The rougher the surface, the greater the force needed. All right. So for those, I noticed some folks in the chat want to join us in the studio, but the studio is full to capacity. So I'm unable to post the link because we just can't take any more at this time in the studio. But please post your answers, post your questions, your comments in the chat, and I will respond. All right, so let's go to another question. And this time I'll ask Amari to read question 25, please.
Okay, Miss. Question 25. Oil is added to the tabletop. Which prediction will likely take place? Question 5. Oil is added to the tabletop. Which prediction will likely take place? A. The force needed will be 2.0. B. The force needed will be 2.6. C. The force needed would be 3.1. D. The force needed would be 3.4. A. The force needed will be 2.0. B. The force needed will be 2.6. C. The force needed will be 3.1. D. The force needed will be 3.4.
All right, so let me see who was listening. What did I explain a while ago? What happens if you add oil or
Miss
water?
would miss less friction would take
It will
place.
create less friction, right?
Yes, miss.
So would we then need more force to move the object or less force to move the
Less
object?
force, miss.
Does everybody agree with that?
Uh-huh.
If we're adding oil to the surface, it will make the surface have less friction. Remember, I said there are certain things you can do to a surface to make it have less friction and make things move easier over it. You can lubricate it, which means to add oil. You can wet the surface. You ever notice when something is wet, it's slipperier, it's easier to move, easier to slide? Or you can smooth the surface, right? Make it smoother, sand it down, and it will rub across. So in this case, oil was added, so a lubricant was added. And Amari is saying, as a result of adding the lubricant, we now are going to need less force. Less. So, does anybody disagree? And if not, then which one of the, let's look back. So they're talking about the tabletop. So let's look back and see what was the force needed for the tabletop. And then we can decide which one would now be needed. So the tabletop, 2.5 newtons.
Miss, then I would say A, miss.
Right, so it has to be less than the 2.5. So the only one here that's less than 2.5 is A, 2.0. All right. Question 26. Analyze and interpret data, draw conclusions. So we're to analyze the results, use the information to draw conclusions. Um, okay. Back to you, Nardika.
Miss, can you hear me?
I'm hearing now.
Okay. Question 26. Some students were carrying out an investigation to determine the best material for soundproofing. These are the steps carried out. They measured the sound level of an alarm from a phone in an open box. They then measured the sound level of the phone alarm in the following situations. 1. When the box was closed. 2. When the box was packed with different materials and closed. Some students were carrying out an investigation to determine the best material.
We're not hearing you anymore, Nadika.
Okay, no, sorry. Some students were carrying out an investigation to determine the best material for soundproofing. These are the steps carried out. They measured the sound level of an alarm from a phone in an open box. They then measured the sound level of the phone alarm in the following situations: 1. When the box was closed. 2. When the box was packed with different materials and closed.
Okay. So let's see now. All right. Jaim, Jaim. Okay. Abriel,
Yes,
can you read, please?
miss.
Go ahead, Abriel. Please read the table.
The results are shown on the table below, where the phone alarm was placed. Open box 80, closed box 70, closed box packed with bubble wrap 40, closed box packed with cotton 50, closed box packed with fabric 55, closed box packed with paper 60.
Again, please.
The open box is 80, closed box 70, the closed box packed with bubble wrap 40, the closed box packed with cotton 50, the closed box packed with fabric 55, and the closed box packed with paper 60.
Okay. So what's happening here? What are they trying to find out? What is the experiment? What's the objective of this experiment? To determine what? To find out what? To investigate, to determine the best material
For
for
soundproofing,
sound.
miss.
What does soundproofing mean? What does it mean to soundproof something?
Miss, to make like, so, miss, for example, if you're in a car, miss, and miss, you're talking to somebody inside the car,
Mm-hmm.
miss, if a person is standing up next to the car outside of the car, miss, and the person cannot hear, that means that the car is soundproof.
Okay. So is it to keep the sound in or let the sound out?
Miss, to keep the sound in.
All right. So when you soundproof a room, you want to keep the sound inside the room, right? And if you're soundproofing a box, you'd want to keep the sound inside the box. So that means you don't want to hear anything coming out of the box. Am I right? That's what a well soundproofed box No matter what's going on in there, you're not supposed to hear it if you are not in the box. So then, if you are measuring the sound coming out of the box with the most soundproof material, would you hear more sound? Would you hear a higher decibel or a lower decibel sound? Remember, sound is measured in decibels, right? So the numbers here with the higher decibels, would that indicate
Miss, you would
a
hear a
better
lower
soundproof?
decibel.
Right, you'd hear a lower decibel because the material would be keeping the sound in the box as much as possible, letting out little of the sound, if any. So therefore, if they're asking us for the best soundproof material, we're looking for the one with the lowest decibel. Am I right? Yes or no? Am I right? Do you understand, students, what we're saying?
Yes, miss.
So we're testing to see which of these materials are better or best at soundproofing. So we're measuring the sound that's coming out of the box, and we should find that the one with the lowest decibel has the material that is best at keeping the sound in. So which one then would we say is the best material for soundproofing? Who wants to go? Which one of these is the best material for soundproofing?
Miss,
All right, let's look at
Miss,
the
no.
options. The
Miss, I
options.
think I know, miss.
Did we read the options? Amari, read the option. Read this page for me, please.
Mm, and Miss, should I read it?
Yeah, read it twice, please.
Which material is best for soundproofing the box? A. Bubble wrap. B. Cotton. C. Fabric. D. Paper. Which material is best for soundproofing the box? A. Bubble wrap. B. Cotton. C. Fabric. D. Paper. Miss, I would say A. Bubble wrap.
All right, so if we go back, we see that the bubble wrap it released 40 decibels of sound. That's the lowest one. And the open box has the highest decibel because the box that's open, all the sound coming out of it, right? All the sound that's being played on the phone coming out of the box. There's nothing to trap the sound in there. The box is open. When you close the box, less sound, but still not no insulation there. But definitely the bubble wrap um, keeps in most of it. So that would be A, the bubble wrap. Question 27, same.
Miss,
Yes, Amari.
Miss, Miss, I'm gonna leave and join back because you're breaking up.
All right.
Yes.
Okay, so again, we're advised to analyze the results, use the information to draw a conclusion. By the way, is everybody else hearing me clearly?
Yes, miss.
Yes, ma'am.
All right. So let's see who else is joining us. I see Genesis, Milan. Welcome, ladies.
Hi, Miss.
Hi. All right. So as soon as you come, I'm gonna give you a job to do. Milan, can you see the screen?
Yes, Miss.
All
I
right.
can
Please
see the
read
screen.
what's on the screen twice.
A student want to determine which material could keep her soup warm for the long time. She carries out the step below. 1. She places the same amount of soup in cups. made of different materials A, B, C, and D. 2. She measured the temperature of the soup in each cup at the beginning and at the end of 10 minutes. A student wanted to determine which material could keep her soup warm for the longest time. She carried out this step below. 1. She placed the same amount of soup in cups made of different materials A, B, C, and D. She measured the temperature of the soup in each cup at the beginning and at the end of 10 minutes.
Thank you, Milan. Genesis, please read the table to see the findings of the experiment.
The student add, adjust,
Obtained
obtained these resolution
results.
results. Material A start temperature 7 degrees Celsius.
70.
B 70 degrees Celsius. N temperature 56 degrees Celsius. B 70 degrees Celsius. 51 degrees Celsius. C 70 degrees Celsius. 61 degrees Celsius. D 70 degrees Celsius. 62 degrees Celsius. The student obtained these
Results.
results. Material A start temperature 70 degrees Celsius and temperature 56 degrees Celsius. B 70 degrees Celsius, 51 degrees Celsius. C 70 degrees Celsius, 61 degrees Celsius. D 70 degrees Celsius, 62 degrees Celsius.
Thank you, Genesis. So the student is testing to see which material will hold the heat of the soup better, will keep in the heat, right? It said the student wanted to determine which material could keep the soup warm for the longest time. So the four different materials, she placed the soup in material A, B, C, and D. So all of them have the same starting temperature because it's the same soup being poured into them, 70 degrees Celsius. But for each of them, after a period, let me see, did they say what period? Did they say what period? 10 minutes. Okay. After 10 minutes, she measured the temperature of the soup in each container. So in container A, the temperature was 56 degrees after 10 minutes. In B, it was 51 degrees. In C, it was 61 degrees. And in D, it was 62 degrees. So what do you think is happening here? What conclusion can we draw from this experiment? What does the change in temperature tell us about the types of material? Anyone wants to have a go? Each of them started at 70 degrees Celsius, and after 10 minutes, some were cooler than some. Well, they were all at different temperatures. So, what can the student determine? Because the student wants to find out which material will keep the soup warm, the warmest. So,
Miss
any
D.
observations? Go ahead.
Miss
What have you
D.
observed? Go ahead.
Miss D.
Who is speaking? Who is speaking?
Miss me.
Nardika? Who is speaking? You have to say your name,
Not
please.
me, miss.
Miss Abel.
Oh, Abriel. So you're saying, let me go back and look. You're saying, C,
No, Miss D.
D, or why do you say D, Abriel?
Miss, because it's more than the rest.
Okay, so D is 62 degrees. So how much heat has been lost from material D after the 10 minutes?
Miss,
Can we
repeat.
work that? How much heat has been lost from material D after the 10 minutes? Remember, it started at 70 degrees. All of them started. And after 10 minutes, the heat in D is now 62. So I'm asking how many degrees Celsius of heat has been lost? From 70 to 62, what has been lost? How much? Anyone? If we started at 70
Miss,
degrees and now it's 62 degrees, how many degrees of heat has been lost? All right, so
3.
how much has been lost? 8 degrees. From 70 to 62, 8 degrees of heat has left the material, has left the soup. So for the C, from 70 to 61, 9 degrees of heat has been lost. For B, 70 to 51, 19 degrees of heat lost. And A, 70 to 56, 14 degrees of heat. So the one that keeps in most of the heat would be the best one. So Abrielle is saying that's D, and she's correct. Only 8 degrees of heat lost from the soup, whereas the others lost 9, 19, 14 degrees. So they lost more heat. So the correct answer is D. D is, oh, they're actually asking for the worst. I didn't see that part. We didn't read the options. So it said which material is the worst. So we have to go back now. So we know that D is the best, right? It keeping more of the heat. Which one is the worst?
Miss B.
B is the worst because it lets out 19 degrees of heat. So within a short time, the soup would be cold if it's allowing the heat to leave so quickly. So you definitely wouldn't want to buy soup cups from material B because the customers would start complaining that the soup get cold on them before they drink off the soup, right? But if you buy material D and serve the soup, they'll be satisfied because they can have their soup and sip it, and it will keep in the heat. They'll still have their nice hot soup to enjoy. So when persons are selling, these are some of the decisions they have to make. They have to decide what material to buy to package their food in, whether they want to keep it warm or they want to keep it cold, or they want whatever condition they want. They have to shop around to find the best material to package their goods so that their customers can be satisfied. For question 28, same targeted skills, analyze and interpret data. So you see, we have to sharpen these skills because they are tested a lot in the ability test. Okay, welcome, Jair. Can you hear me? All right, Jair isn't responding. Milan, can you read, please? Okay, Abriel.
Mr. Smith wants to determine the best brand paper towels he should use in his kitchen to soak up water by carrying out an investigation. The number of pieces of paper towel used to soak up 150 milliliters of water in each case is given in the table. Paper towel. Brand A, the number of pieces used is 8. Brand B, the number of pieces used is 4. Brand C is 6 and brand D is 5.
Five. Five. All right, read it again, please.
Mr. Smith wants to determine the best brand paper towels he should use in his kitchen to soak up water. By carrying out an investigation, the number of pieces of paper towel used to soak up 150 milliliters of water in each case is given in the table. Paper towel. Brand A, the number of pieces used is 8. Brand B, the number of pieces used is 4. Brand C is 6. And brand D is 5.
Okay, thank you, Abriel. Okay, Nordika, please read the options.
Okay, miss. Which is the best brand paper towel for Mr. Smith to use? A. Brand A. B. Brand B. C. Brand C. D. Brand D. Analyze the results. Which no. Will the best brand use more or less pieces? Which is the best brand paper towel for Mr. Smith to use? A. Brand A. B. Brand B. C. Brand C. D. Brand D. Analyze the results. Will the best brand use more or less pieces?
So answer that question, somebody. Would the best brand be the brand that uses the most pieces or the least pieces to pop up the
Mr.
same
Lee,
amount? Why the least?
Miss, because it's the best brand, that means it uses less pieces of paper towel.
Okay, but why? Why are we saying we're looking for the one with the least? In terms of think in terms of durability and cost, because if you're if you're using 4 pieces to mop up the same amount of water as you'd use 1 piece for the other towel, what would it mean you'll have to do after that? What would happen to that roll of paper towel? When you have to use 4 pieces instead of just one, what's gonna happen after that? You'll have to buy more within a shorter time, right? Am I right?
Yes, Miss.
Right. So it seems like you're not here. You guys not hearing me properly. You're not responding well this evening at all. Right. So if I have to be using
Miss,
several
it's because you're
pieces,
breaking up a little.
huh?
Miss, you're breaking up a little.
Yeah, I realize that. Because you guys are not responding like how you usually respond. Yes. So you're gonna have to buy more within a short period of time, and of course, it's going to end up costing you a lot more money. So even though the better brand might be a little more expensive at first, when you're buying it, but because it's more durable and it's gonna last longer, you actually might end up paying less in the long run because you're going to have to be buying more of the inferior quality one. So let's go back to the table then. Which is the best brand?
Miss, the best brand is brand B.
Brand B, because only 4 pieces of paper towel were needed to mop up the same amount of water. And which would we say is the worst?
Miss, brand A.
Miss Brand Amy said.
Right. So this question is asking for the best. I remember you have to look carefully because, like with the question a while ago, they were asking for the worst or the least. So you have to be careful to see, do they want the best or do they want the worst? So we're saying brand B is the best. Right, brand B is the best. Question 29. So what's happening here? A rocket. All right. Jahim, I've not been hearing from Jahim for a while, and I was calling Jair. And Jair, can you hear me?
Miss, can you hear
Jair,
me? Miss, can you hear me?
who is asking?
Me, Jair, Miss.
Hmm?
Me, Miss Jair.
Oh,
This is
Jair.
Jair asking.
Jair sound like him the weird on a Montego Bay. Jair, you sound like you're the way a Montego Bay a call me. All right, go ahead and read, please, Jair.
Adding baking soda or powder to vinegar in a bottle can
Can you read
make
louder though?
Miss, my mic is not really working, Miss.
All right, go ahead. Go ahead.
A student wanted to find out how the amount of baking soda would affect the height of the rocket. The results are shown in the table below. Use the information to answer item 29.
All right, Jair, since your voice is so low, I'm going to ask somebody else to read it again for me. All right. Nordika, can you go?
Miss, can you hear me?
Yes, I can.
Okay, Miss, because my PC is not really doing good. Anyways, added baking soda or powder to vinegar in a bottle can create a rocket. A student wanted to find out how the amount of baking soda would affect the height of the rocket. The results are shown in the table below. Use the information to answer item 29. Adding baking soda adding baking soda or powder to vinegar in a bottle can create a rocket. A student wanted to find out how the amount of baking soda would affect the height of the rocket. The results are shown in the table below. Use information to answer item 29.
Thank you, Nordika. Donnell,
Yes, miss.
good night. Can you read, please?
Yes, miss. Table showing amount of baking soda and height of rocket formed. Tea, teaspoons of baking soda. 1. Rocket height centimeter 70. Teaspoon of baking soda. 2. Rocket height centimeter 130. Teaspoon of baking soda. 3. Rocket height centimeter 170. Teaspoon of baking soda. 4. Rocket height centimeter 180. Table showing amount of baking soda and height of rocket formed. Teaspoon of baking soda 1. Rocket height centimeter 70. Teaspoon of baking soda 2. Rocket height centimeter 130. Teaspoon of baking soda 3. Rocket height centimeter 170. Teaspoon of baking soda 4. Rocket height centimeter 180.
Thank you, Donnell. What pattern can we find here? We're to analyze the information and decide what pattern. The more teaspoons of baking soda, what's happening to the height of the rocket?
It increases, miss.
It's gradually increasing. Is it increasing steadily, a fixed amount each time? From 70 to 130, how much is that added? From 70 to 130, what was added in height? 70 plus what gives 130?
6.
60, right? All right, so when we added one more teaspoon, we sent the rocket 60 more centimeters up, right? From 130 to 170, how much was that?
40.
40.
40.
Okay. So we add another teaspoon and it sent it up 40 more centimeter, not another 60, 40 more. And when we added the fourth teaspoon from 170 to 180 is just what?
10.
10.
Just 10. So it's not increasing steadily. It's not going up by the same amount each time. It's going up, but it's going up by less and less each time. Do you observe that? So if we what can we assume if we keep adding more baking soda based on this trend? Do you think it will get to a point where no matter how much baking soda we add, it will not go any higher? Can we assume that based on the trend? Because we keep adding 1 teaspoon. First, it went up by a lot, almost twice as much. The first teaspoon extra we added, it went up by almost twice the height of the original. And then we add another teaspoon, it just go up 40. And we add another teaspoon, it just go up 10 more. So maybe if we add another teaspoon, it go up to the same 180. Who knows? But based on this trend. So let's see what they want to find. Let's see what they want to find. Okay, Braille, can you read for Abriel? Can you read for me, please?
Miss, Miss, can you repeat?
Please read what's on the screen, Abriel.
What is a likely conclusion from his investigation? A. As the amount of baking soda increased, the rocket height increased. B. Baking soda reacts with bottled vinegar. C. If the amount of baking soda is increased, then the rocket height will change. D. When baking soda and vinegar are mixed, a rocket is produced. What is a likely conclusion from his investigation? A. As the amount of baking soda increased, the rocket height increased. B. Baking soda reacts with bottled vinegar. C. The amount of baking soda is increased and the rocket height will change. D. When the baking soda and vinegar are mixed, a rocket is produced.
Okay. What do you say, scholars? What do you say? Which one? Did we create a rocket when we mix the baking soda and the vinegar?
Miss, Miss,
Did we
Miss,
create a
is it
rocket?
Miss A?
So you're saying A, as the amount of baking soda is increased, the rocket height increases. Does anybody agree or disagree? So I'm asking, by the way, did we create a rocket? Did we produce a rocket when we mix the baking soda with the vinegar? Yes or no? That's an option there. We didn't actually create a rocket, we just gave the rockets a propulsion. We propelled it into the air by the reaction because the vinegar and baking soda, they react together. B is saying that they do react, but that's not the conclusion that happened. But the conclusion must be something that we observe based on carrying out the experiment. What change occurred, right? What actual change occurred? What actual pattern did we notice? So A is correct. Um, but let me see C. If the amount of baking soda is increased, okay, the rocket height will change, but we have to say specifically it increased. So A is correct. But we also have to note that based on the trend, it doesn't stand to reason that it will always keep increasing. Because based on the trend, it was increasing by less and less each time. So it seemed to me that it was getting to a point where it would flatten. It would get to a plateau and then either just stopped increasing no matter how much more baking soda you put, or started to decrease, because sometimes that happens as well, where things will get to a point and then the more you add, they will actually start decreasing. We saw that yesterday. Those who were on yesterday, we saw that with the fertilizer that was added, the more fertilizer added, the plant height increased, but then it got to a point where when you added more, the plant height actually started to decrease. So these are observations we have to take note of, right? We can't just, especially when you see when the numbers are telling you that something is happening, it might get to a point and then something else might start happening. We're going to stop there for tonight. We're going to stop there for tonight and continue tomorrow, same time, same place. Amari, did you miss some of it? I know your device wasn't working too well in the middle there.
Yes, miss, the phone kept kicking me out, so I had to use the computer.
Oh, so you might have to go back and watch over that little part there. The part that you miss. We don't want my grade six scholars to miss anything. Okay? Because you have to be sharp
Yes,
and
miss.
ready. Yes. Especially my grade six scholars. Try not to miss anything at all. All right, we're going to continue tomorrow. Same time, same place. Have a good night.
Bye, miss.
Thank you, Miss.
Bye. See you tomorrow.
Bye.